Hello and welcome to another video. This time we're going to be looking at using interrupts on the Agon. More specifically, timer interrupts. So what do we mean by an interrupt? Well, an interrupt is anything that might literally interrupt your own program because it needs priority attention. This might be another piece of hardware communicating, such as keyboard presses from the VDP. This is a list of the interrupts which might be useful for us. There are 6 different timer interrupts available. We can get an interrupt message when data comes in through the serial port, UART1, and we can get an interrupt on any of the I/O ports. We'll save those for another day. This video is going to focus on a timer interrupt, and we're going to use a programmable reload timer, number 1. So what is a programmable reload timer? Well, it has a few different features. It can be used a little bit like an alarm clock. You can set it a given time and it will tell you when it's reached it. And in the meantime, you can get on with your own code. What we're going to look at today is a timer which beats like a heartbeat. We'll give it a frequency of how often it beats. And every time it beats, it'll tell us. And each time it tells us, we can then do something. In this example, we're just going to increase a counter. But in your program, you could be doing anything at that point. You could be animating objects around the screen, changing sounds, or maybe a countdown of the amount of oxygen left in a cave game. If we look at the program, we'll see what it does first. There's a simple title being printed, telling us how often it's actually beating. And the counter below shows us an increase with every beat. Here we've set it to beat at about 10 times every second. You can see the counter counting up. This is all in hexadecimal. So let's take a look at the program. At the start, we've got a few macros. These are just so that everything is in one file. We then initialize the Agon in the same way we've done before. We jump to the Start Here section, and the first command that we haven't seen before is this one, im2. This means we're going to set interrupt mode 2. Now the Agon should be running in interrupt mode 2 by default, but just in case something else has changed it before your program, we'll make sure we're running in this mode. Clearing the screen, setting the cursor are 2 fairly obvious macros that we've defined above, and setting a tab to a certain position. This is simply so we can print the title on the screen. We're going to reset the counter that we're going to be printing and set the frequency of the timer to 10. We'll load this into a local variable here. We print this and then we print the Hertz message. So all of this is simply the title that's on the screen. The next section is quite important because this sets up the timer running. These are all functions which we'll look through in a moment. We've got stop timer. We do this first just in case the timer is already running, set by somebody else's code. We're going to set the timer frequency. We load HL here with the address of the routine that we want called at every heartbeat. And then we'll set that. And then we'll start the timer. And from this point on, every time the heart beats, a routine will be called at the address here, which we've defined. If we look at our main program loop, you can see that it's not really doing much. All it's doing is finding out if a key has been pressed and if it's the escape key. And if it does, we exit. So how did it actually update all those numbers on the screen? Because they're not here. Well, that happens within that interrupt service routine that we defined. So with those functions that we called earlier, one of them was start timer, and this is where we define what the settings are for the timer, and then we send that out to our timer's port ID. When we set the timer's interrupt service routine, we arrived with the address timer ISR, which is the routine we want called. That's in HL, and then we simply do a MOS call to set that up. If we look at the MOS specification, it says that we need E to contain the interrupt vector number and HL to contain the address of where we want it to go to when the event happens. The interrupt vector number is the one that we saw in this chart, in this case 0C. To set the timer frequency, we arrived with a number that we wanted of how many times we wanted that beat to happen per second. We also have a default reload time. Dividing that by the frequency gives us a number that we can set. We set it into 2 different bytes for the timer. Stopping the timer is very similar to the start timer, except it disables it rather than enables it. And so this is where all the action happened. In our interrupt service routine, this is what gets called at every beat. First, we use the command DI. This disables interrupts. This is because we don't want any other interrupts to happen whilst we're doing this short routine. It's also really important that we store and later restore any of the registers that we might be using, because when we come out of this routine, our program needs to carry on as it was before, because it will be literally interrupt mid-process. Here we get a value of our timer control. This tells it that we've understood that we've read the actual heartbeat. These next 3 lines are quite simple. We're getting a counter, we're increasing it and storing it again. And finally, these few lines here print that number to the screen. We then make sure we restore the registers that we might have used. We enable interrupts again, and we return. Notice how this instruction is slightly different to a normal function. reti.l returns from an interrupt routine. Further down the file, you can find some of the other functions that have been called if you want to look through them. You will also find some of the constants that we used above. You can set the interval of how often the timer beats, anything from just a few ticks of the processor up to about a second. So maybe you can find a way of including a programmable reload timer in your projects.